Hi and welcome to Gaffy's Grinds. You're very welcome to the channel if this is your first time here. If not, you're very welcome back. In these videos, we try to take concepts from junior cycle science, we break them down into small manageable pieces and we try and help you understand them, and then we do some practice to help you commit the information to your long-term memory. So practicing, when I ask you to do things like doing different tasks or doing different questions, it's really important that you actually give your full effort to doing the task. They're very carefully designed to make sure that they encourage information to go to your long-term memory so that you learn them properly. And I know all you guys are here to learn, so that's what you want to do. So it's really important that you give the activities and the questions your full effort, your full attention. Something that's going to stop you from doing this are distractions and things which can distract you. The main distraction we all have is our mobile phones. So if you can't, I'm going to do the same with mine. I want you to put your phone onto silent now so that it doesn't distract you, or even better, put it on do not disturb so no notifications come up at all. Once you're finished with the video, you can go back to doing whatever you like once you're finished giving it your full effort. This is the first video in our series on electricity. And today we are going to learn about something called charge. Before we do, we need to recap something. So I just want you to imagine this scenario here for a second. I've got two dishes, and into these dishes I have two different substances. One of them is a blue substance. We've seen this substance before. We've seen a substance which is blue before. There are more than one blue substance, but a substance which is blue. So this is blue, and it's known as copper sulfate. We saw it before when we talked about crystals, copper sulfate. Another substance that we've seen is a yellow colored substance. It's more of a powder than a crystal. And this is a yellow substance. And its name is sulfur. It's a powder, sulfur. I also want to take the idea that if we have a liquid here and in a different beaker, so I'm drawing two beakers, and into these beakers I am putting liquids. There's one liquid, there's liquid A and there's liquid B. And what we're going to do to them is we are going to heat both of them. Okay. So this is heat. And we are going to heat them until they boil. Now, when they boil, there will be steam. But how else can we know? Or sorry, yeah, there will be steam. That's what will tell us that it's boiling, and we will see bubbles. We'll see bubbles of gas forming inside the beaker. And if we wanted to find out what the temperature it was that it was boiling at, we would use, what device would we use? So on 3, I want you to speak your answer to the screen. How would I know what the temperature was? What piece of equipment would I use? So on 3, I want you to answer by speaking your answer out loud to the screen. 1, 2, 3. Okay, I hope that you guys said you would use a thermometer. So here I am drawing a thermometer. Thermometers measure temperature, and I'm going to put the thermometer into both beakers and measure the temperature. Now, say for instance, this one is boiling and it's got a temperature, it's got this red liquid inside, which moves up the thermometer when it gets warmer. That one's boiling, and as you can see, the temperature there is quite low. This one is also boiling, but as you can see here, the temperature is much higher in this one. And that is because it has a higher, what we call boiling point. So boiling point is the temperature at which a liquid turns to a gas. And these different substances, A and B here, have different boiling points. Again, that's not new information to us. We've seen this before. So this is what we refer to as the boiling point. And this over here is what we refer to as color. These have different colors. These have different boiling points. Well, what are these things? These are features of these different materials. So copper sulfate has the feature that it is a blue color. Sulfur has a feature that is a yellow color. So they are different by that feature. And these are features that we can see. So we can see, we can use our eye, and we can look and observe that the color of copper sulfate and sulfur are different colors. Or we can see or measure. So we can use a thermometer and we can actually see on the thermometer then that the boiling points are different. These features of a substance or features of different materials that we can see or measure, we refer to these things as properties. So that's what we call a property. So color and boiling point are examples of properties. These are features of a substance or of a material that we can measure or we can see. Okay, so these are features, properties of features of a substance that we can see or we can measure. Some people think that if I was to ask you about properties of a solid substance, some people think that the fact that the particles of a solid are regularly arranged, okay, the properties of a substance are regularly arranged, the fact that people would say that that is a property. Well, we draw solids like this. We draw particle models of a solid like this. This is a correct diagram for a particle model for a solid. But the thing is that if we try to look at a solid, sorry, that's not a very good eye. If we try to look at a solid, we cannot see the particles. We're not able to see that. This is all just a model. So the way the particles are inside is a model which helps explain certain things. For example, we know that some substances have higher boiling points. So this one over here, for example, this one I'm putting a star under, this one has a higher boiling point because the forces that hold the particles together down here, these forces that hold them together are higher. So if you've got stronger forces between the particles, it needs more energy to overcome, which means it has to be at a higher temperature. But this is not a property because you cannot see it. So it's not a property. So something inside the substance, like how the particles are arranged or how the forces hold them together, these are not properties. Why? Well, you cannot see them. These are more to do with what we call the structure. Okay, so these are not properties, they are structure. So the forces in between the particles or how the particles are arranged or whether they're touching or not, that is not a property. Things we can see, like the color and the melting point or the boiling point, those are properties. Okay, so different substances have different properties. One such property is called charge. Now, it's a little bit difficult to fully explain what charge is, but basically you need to know that there are three options for charge. All substances have charge, and there are three options. So some have a positive charge, other substances have a negative charge, and some have no charge at all. So when discussing electricity, we're most interested in the charge of what we call the subatomic particles. Now, what is a subatomic particle? Well, this is quick revision for us. We've done this before. Subatomic. I'm going to write this word, subatomic particle. Well, particle just means piece, or small piece. Atomic refers to atom. And sub means below, or smaller, or within. Within. It's like in English when you have a heading and a subheading. The heading is at the top of the page, is the main thing. The subheading is below or within that main heading. Okay. Subatomic then basically means the particles inside an atom. So very quickly, just a quick recap. In an atom, we would have learned that there are two types of particles that are found in the middle of the atom. I'm drawing two here in red and I'm drawing two here in blue. Okay, what was the name of the red and blue particles that are found in the center of the atom? If you can remember this, I'll be really impressed. So on three, I want you to speak your answer to the screen. What are the red and blue subatomic particles called here? 1, 2, 3. Okay, so they are protons. Well done if you got that. And now that I've said one of them, that might clue you in for the other one. So if you didn't get the other one, maybe you will now. On 3, 1, 2, 3. Okay, the other one found in the middle is called the neutron. So subatomic particles, we've got protons and neutrons, and they are found in the center of the atom, and this space is what we refer to as the nucleus. Nucleus means center. So nucleus is in the middle of the atom, and the protons and the neutrons make up the nucleus. Okay, there was one more type of particle, and it's found, I'm going to draw it in green, it's found out here, circling around the nucleus. What is the name of the green particle? On 3, 1, 2, 3, speak your answer now to the screen. Okay, I'm hoping that you said it's called the electron. So we've got protons, neutrons, and electrons. So that was a quick recap. Shouldn't be anything very new here. But we're interested in the charges on these particles. So basically, when we're discussing electricity, we're most interested in these things. So we have protons, which have a charge of +1. So we have protons, and the charge on a proton is +1. So protons have a charge of +1. We have electrons, and electrons have a charge of -1. It's the same size as the charge on a proton, but they're opposite signs. So we've got +1 and -1. We've then got the neutron, and neutrons don't have any charge. So we write it as a 0, no charge. Okay. So just to recap, protons have a charge of +1, electrons have a charge of -1 or negative, and neutrons have a charge of 0. So this can be referred to as a positive charge because it's got a plus sign. This one can be referred to as a negative charge because it's got a minus sign. And this one is referred to as a neutral charge because it's got no charge. So something is neutral if it has no charge. Okay, that's a really important thing to try and remember that there, okay? Charges of subatomic particles are +1 for protons, -1 for electrons, and 0 or neutral for neutrons. Okay, so what I'm going to do now is I am going to flip the screen up, and what I want you to do is pause the video, and in your notes copy, I want you to try and remember what was in that table. So pause the video now and try and write down the table I've just drawn for the charges of the 3 subatomic particles. Okay, so you should only be watching the video now if you pause the video and you try to remember what are the 3 subatomic particles called. Okay, so they were called the proton, the neutron, and the electron. So well done if you remembered all 3 of those, so listed underneath each other. And then what is the charge for each one of them? So if you didn't already do that, now that I've given you the 3 names, maybe you can remember what the charges were. Pause the video and finish that now. Okay, so this is what you should have. Protons have a positive charge +1, electrons have a negative charge -1, and neutrons have a neutral charge 0. Now, like I said, it's really difficult because it's quite complicated to explain what charge is, but charge is a property. Okay, it's a property that can be positive, negative, or neutral. That's all we can say about it for now. So charge is a property. It can be positive, negative, or neutral. An example of something that's positive is a proton. An example of something which is negative is an electron. And an example of something which is neutral or has no charge is the neutron. Okay, it's time to do some questions. Okay, so here they are. What I want you to do is I want you to now pause the video and I want you to have a go at these questions. Okay, so pause the video now and have a go at these questions, please. Okay, so you should only be watching the video now if you have tried to do those 4 questions for me. These are the answers coming up. This is what you should have. Okay, so question 1 said, what is a property? A property is a feature of a material that you can see or you can measure. Well done if you got that right. A property is a feature that you can see or measure. Name a material is a gas at room temperature. What can you say about its boiling point? A material that is a gas at room temperature must have a low boiling point. It's already a gas at room temperature. Room temperature is quite a low temperature. It's only about 20 degrees. So that's quite low. If it's already a gas, it's already boiled. We say it's a low temperature. Well done, if you got that right. Name the 3 subatomic particles smaller than an atom. Okay, so you can either draw this or you could have just made a list. You can draw like I have already done. So you've got out here, you will have the electron like this. This is the electron. And it's always a good idea, just because we're talking about charge, say that's a -1. Then a different color here in purple this time, just to show you it doesn't really matter what color you draw because this is only a model. I'm drawing 2 protons here. So there is my purple one. This is protons. And what would the charge on a proton be? So on 3, speak your answer out now. 1, 2, 3. Hoping that you said the charge on a proton is +1. And then a different color again, just to show you it really doesn't matter. Pink. Here's a pink one. There's 1 and 2. And these are the neutrons. And what charge do they have on 3? 1, 2, 3. They have no charge, neutral. Okay, last question. Anne says that a property of solids is that they have strong forces between their particles. Explain why she is wrong. Anne is wrong because these forces can't be seen or measured. They are part of the structure of the substance. They are not a property. So the key thing there is they are not a property because they can't be seen and they can't be measured. So try and make sure you had that in your answer. All right, well done. All right, it's time to continue now. We now know about charge and we know about the charge of the subatomic particles. So just very quickly again, what charge does a proton have on 3? 1, 2, 3. Protons have a plus charge. What charge does an electron have on 3? 1, 2, 3. Speak your answer. Charge on an electron is negative. And then charge on a neutron, please, on 3. 1, 2, 3. A neutron has no charge, 0. Okay. A property is just a feature of a substance that we can see or we can measure. Okay. Now, we're going to continue discussing charge because it's important to help us understand how electricity works, what electricity is. Okay. Now, in some materials, specific materials that we're talking about here are metals. When we have a metal, electrons are free to move around. So if we have this material here, say, if it's a metal, it's going to be a solid most likely. So here I am drawing a solid material. So I'm just going to draw, that's a bit, I don't like that one now. I'm just going to draw that one a bit bigger. So I'm going to draw 6 atoms like this. And this is a solid. Most metals are solids, nearly all metals are solids. So this is 6 solid atoms, and this is a metal. Now say we take our metal and we were to just roughly draw the electrons. Now in a metal, special thing about a metal is that the electrons can move around much more than they can in other types of substances, in non-metals. So what I'm showing here is that they are free to actually move between the atoms. So they are free to float around. They're what we call free electrons. Free electrons, which means they don't necessarily stay stuck to one particular atom. So they're free electrons, also sometimes called delocalized electrons. Now, why delocalized? Well, local refers to the region. So our local area is where we live. Now, delocalized, basically, if you were delocalized, that would basically mean you don't stay where you live. You don't stay in Calvin all the time, for example. You don't stay where you live. Delocalized means you are able to move away from where you live. Well, delocalized electrons are electrons which are able to move away from the specific atoms that they are attached to. So they're able to float around in what we call this sea of electrons. So we got this term in science we refer to a sea of electrons that exists in metals. I don't want you to worry too much about the sea of electrons. It's a little bit beyond junior cycle science. Don't worry about too much. Just know that they are free, that they can move. Okay. Now, any material like this that has free electrons is going to be what we call a conductor of electricity. We've seen that word before. Conductor means electricity can pass through it. Now, if we take a conductor like this metal and we stretch out the atoms and turn it into a wire. So here we've got the atoms spread out, stretched out, and we're turning them into a wire. And then let's say we make a closed loop, so like this. So we stretch out the atoms into a wire and we make it into a closed loop. Closed loop basically means it's a continuous loop. Now we say now that an electrical circuit has been made, and the reason for this is because the sea of electrons are now free to flow around and around in a circuit. Kind of like when you go-karting, the lap or the track is called a circuit because you can go around and around it. Okay, so this is what we refer to as a circuit, and basically what we can see is now the electrons could flow around the circuit like this. Now, if the electrons all start to move in one direction like this, sorry, before we go on to talk about that, I should say that this is now called an electric circuit because the electrons are free to move around in a circuit or in a circle, so an electric circuit. Now, if electrons all start to move in the same direction as shown by the arrows here, so if they move in the same direction, we say that the electrons are flowing. So to flow means to move in the same direction. So if electrons are flowing, they are moving in the same direction in the circuit. So that means here, as you can see, this direction here is clockwise. So all the electrons will start to flow clockwise. Then that means that they are flowing if they're all moving in the same direction. Now, because metals have free electrons or delocalized electrons, so metals have delocalized electrons, we call them electrical conductors. And the reason for this is they allow the electrons to flow around inside them. So electrical conductors allow electrons to move freely inside them because they've got free electrons. And these electrons can then carry around energy, and that is what electricity is. So if a material does not have free electrons, then they cannot carry energy around inside the material. Okay, it's time to do some more practice questions now. Okay, here we go. So what I want you to do is, these are 6 questions. I want you to pause the video and from memory, again, without looking back at any notes that you might have made or any of the diagrams, I want you to pause the video and give them questions your best effort now, please. Okay, guys, so you should only be watching the video again now if you have had a go at doing all of them questions. So the first question is, what is charge? So charge is a property of materials. That's what it is. Charge is a property of materials. It's something that we can see, we can check, and we can measure to see if there's a charge inside. If a material has charge, we can measure it. So it is a property. What are the 3 options for charge? Again, I'm hoping this one was pretty straightforward after that explanation. Charge can be positive. Now that I've told you that, if you didn't have a clue what that question was about, you can pause the video and finish the other 2 now, please. Okay, so it's positive, negative, or neutral. Okay, they are the 3 options: positive, negative, and neutral. Well done if you got those right. If not, you need to fix them now. I will put the answers up in a second so you can see them written down if you need to make changes. Number 3, from memory, what is the charge on a proton? Protons have a +1 charge. Neutrons have a neutral charge, and electrons have a negative charge. So +1 for proton, 0 for neutron, and -1 for electron. Well done if you got that. Brilliant, guys. What needs to be done to a wire before we can call it a circuit? Okay, so you remember when we talked about making a circuit, we said that the wire had to be made into a closed loop. So it has to be one continuous loop. So the wire, if it's stretched out straight, that is not a circuit. It is only a circuit when we make a closed loop from it. I'm hoping that you guys were able to see that. So well done if you got that right. When this happens to a wire, the electrons can flow. Explain what this means. So really we had to explain, what does the word flow mean? Okay, so I'm hoping that you guys remember that from the video. Okay, so basically what we're talking about here, what does flow mean? It means that they all move in one direction. So well done if you said that. If the electrons start to move in the same direction or all in the one direction, then good. That could be clockwise or anti-clockwise, but so long as they're all going roughly in the same direction, then that means that they are flowing. Why do we use metals to make circuits? We use metals to make circuits because they are conductors. Why are they conductors? Well, it's because they have these free electrons inside. Okay, so those are the correct answers. Here they are, if you need to see them written down. If you're struggling with any of this, guys, I would suggest that you stick a comment in the video. If you need me to go and maybe make another video just explaining one little bit of it, then I can do that. But stick a comment down below, please. Okay, so that is the next set of 6 questions. Right, we've got another little bit to explain now. Okay, so back over here. First of all, I just want to explain a little bit about electrons. Electrons are what we're really interested in for electricity. So that's what we're going to be focusing on. Now, electrons are incredibly tiny. Really, 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 like unimaginably tiny. If you took a small piece of metal, there would be billions and billions of electrons in it. Now, it's really important for scientists to talk about how many electrons there are in a particular circuit. But because there's going to be so many, like billions and billions and billions, we're going to actually use a different way of describing how many there are. We're going to use a word. Scientists use the word Coulomb. I'm going to write that down. C-O-U-L-O-M-B. A Coulomb. Everybody should say that. Practice saying that on 3 to the screen. Coulomb. 1, 2, 3. Coulomb. Okay, so it's a Coulomb. To describe a really enormous number. We use the word Coulomb to describe a really enormous number. That number is actually 6 quintillion. Okay. Now, before I go and explain any more, that's probably going to seem a little bit confusing. I'm just going to draw a couple of diagrams down here. So I want you to focus here on what I'm doing. I am drawing a box. And that box, I want you to imagine, is a box of eggs. A box of eggs. Bakers, or even your parents, people who buy eggs, will often refer to this box of eggs as a dozen. D-O-Z-E-N. I'll have a dozen eggs, please. And everybody, or most people, well, you come to learn what that word means. It's a word that means a number. It means the number 12. So dozen means 12. So if you are getting a dozen eggs, you're getting 12 eggs. If you were getting, you could also have a dozen mobile phones, which means you have 12 phones. I don't know who would have 12 phones, but you could have a dozen euros, which would be 12 euros. You could have a dozen Skittles, which means you've got 12 Skittles left. I've got about a dozen left. People use that phrase. I'm going to draw another diagram now. I'm using a box. I'm drawing a box. It's about half of the size as the first box. And this is another box of eggs. Oh, sorry. I hate when this does this. Box of eggs. And this box is only a half dozen. Okay, so how many eggs would this be? On 3, I want you to speak your answer out to the screen. Easy peasy, right? It's half of a dozen, which is half times 12. Half times 12 is 6. Most were able to do that in your head, no problem. But the key thing here is to remember that this is just a word that means a number. Coulomb is another one of these. If we took an electric wire, which I'm drawing here as a grey, I'm going to just select grey here. I'm drawing as a grey wire. Okay, and so it's an electric wire. It's made of metal. It's a conductor. And it's a conductor because it's got all of these free electrons in it, which I'm drawing as red dots. Sorry, I went a bit quick there and they weren't perfect dots, but you get the idea. These are electrons in red. Well, remember, these are tiny. These are so tiny that even that little piece of wire there is going to have billions of electrons. Now, I haven't drawn billions because I'd be here all day, but I'm just drawing a few. But there are billions and billions and billions and billions, just so many to count. It gets really, really hard to count. And it gets really hard to read these numbers and write them down. Okay, so we use the word Coulomb. Sorry, I better spell it right. We use the word Coulomb as a word to describe a number for electrons. Now, we don't just use it for Coulomb, for electrons. We can use Coulomb for anything, but we're generally talking about electrons. So if you see Coulombs, we're usually referring to electrons. The number is 6 quintillion. I'm not sure if you've ever even heard of that word, but it's a 6 with 18 zeros after it. So 18 zeros. So 1 quintillion is 1 with 18 zeros. So there's 1 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, that many zeros. Now you can see how that's going to get really annoying to try and write down that number every time you want to talk about a quintillion. It's also going to be really hard for me to read that, look at it, and know that there's 18 zeros there without counting them every time. So it's just much too difficult to use numbers that big. Okay, so 6 quintillion, this is 1 quintillion here. So 6 quintillion, I would multiply it by 6, and that would just replace the first number 1 with a 6 instead of 1. That would be 6 quintillion. And this here, this is a coulomb. 1 coulomb is 6 quintillion. It's much easier just to write coulomb than to write that big long number. Now, obviously, if I had 10 coulombs, I keep spelling this wrong, so it's C-O-U-L-O-M, so that's one you can get wrong really easy. So 10 coulombs, what would I do to find out how many electrons that is? Well, I would obviously take my 6 quintillion and put a 10 times in front of it, 10 of those, and that would add on another 0. So I'd have 19 zeros after it. So I would have 60, I don't even know what that next number is called. It was 60 quintillion, okay? So that's just crazy numbers. It's much easier to use the word coulomb instead, okay? So this will be 60 quintillion. I should probably write here. Okay, so we're gonna be referring to a coulomb of charge, because coulombs of charge is how we measure the electrons that move around in a circuit. So every coulomb of charge is 6 quintillion. So I'm going to be asking you to work out some of these in a second, but it's nothing to be afraid of. It's just a word that means a number, the same as a dozen is a word that means a number. It is a much bigger number, but that doesn't really matter. You just need to know what a coulomb means. We're using it to measure, to describe the number of something. In this case, we're usually talking about electrons, but I could have a coulomb of eggs. In fact, I think I've seen before a fact that in all the eggs that have ever existed, in all the time that chickens and other birds have been laying eggs on the planet, so for all the millions of years that eggs have been getting laid, there still has never been a coulomb of eggs. So if you count up all the eggs from all the history, we're still not at this number. We're not at 6 quintillion. It's just too big of a number. Okay, so you could technically have a coulomb of eggs, but it's never happened. Okay. Right, so what I'm going to do now is we're going to do a few more questions, okay, because this is what this channel is based on, guys. It's always based on practice, this channel. Practice to make sure we strengthen that you're learning and it goes into your long-term memory. That's what we're all about on this channel. So what I want you to do is I want you to pause the video and just try question 1 first. These are tricky, so I want you to just try number 1 for now. Okay, so pause the video and try that now. Okay, so this is what you should have, guys. You'll only be watching the video if you've done question 1. A piece of wire has 6, and that is, I can tell you that is 18 zeros after it. So it has 6 quintillion electrons in it. Why is it easier for electrons to use the word Coulomb when describing that piece of wire? Well, it's pretty straightforward. It's easier to describe, to use, to read, and to write this word than that big long number 6 quintillion. And to write out all those zeros every time, it's easier to use a word. So see what I've written over here is the answer. It's easier because this is an enormous number, which takes a lot of time to read, to think about, and to write down. Okay, so that's why we use the word Coulomb instead of that big number. Let's take a look at number 2. If 1 Coulomb is approximately 6 quintillion electrons, how many electrons are in? Now, if you take a look at question 2 here, and you know I can do that without Sir's help, then you go ahead, pause the video, and go and do the rest of number 2. If not, I'm going to do the first one for you now, and then you can do the other 2. Okay, so 1 Coulomb is approximately 6 quintillion. How many are in 2 coulombs is the first question. Well, if I've got 1 Coulomb is 6 quintillion, then how much is 2 coulombs? Well, I just need to multiply this by 2. So 2 by 6 quintillion, 12 quintillion. Okay, so just multiply 2 by the 6, 12 quintillion. Right, guys, you should be able to do the rest of these now. So I want you to pause the video and try and B and C. Okay, so here is B and C. You should only be watching the video if you've got B and C done. So we then, for half a coulomb, we take our 6 quintillion and multiply it by a half. So you can do this as half as a fraction, or you could do it as 0.5. And that's going to give you 3 quintillion. Well done if you got that right. That was the hardest one of these, I think, maybe, or the 6th of it is maybe as challenge. So we've got 6 quintillion is 1 coulomb, but we don't have 1 coulomb. For C, we have a 1/6 of a coulomb, so 1 over 6. So we do 1 over 6 by 6 quintillion. You're just going to get 1 quintillion. Okay. All right, so well done if you got those right. Great job. Explain why metals conduct electricity. Pause the video, answer the question. Okay, metals conduct electricity because they have free electrons, or they have delocalized electrons. So that's what you should have for your answer. Well done if you got that right. So metals are conductors, or they conduct electricity because they've got free or delocalized electrons inside them. Number 4, a student says this piece of wire has 6 coulombs of electrons moving through it, which means it has 6 electrons moving through it. Explain why the student is wrong. So if you need to have a read of it again, I'd suggest you pause the video if you need more time. So this wire, I'm just going to have a quick read. This piece of wire has 6 coulombs of electrons moving through it, which means it has 6 electrons moving through it. Is that correct? It's not correct, but you have to explain now why is it wrong? Why is that wrong? So go ahead now and try and answer number 4. This is what you should have, guys. Number 4 down here. The student is wrong because 6 coulombs is 36 quintillion electrons, not just 6 electrons. 6 electrons is 6 electrons. 6 coulombs of electrons is a much bigger number. It's 6 by 6 quintillion. So it's 36 quintillion. It's way more than 6. Okay. What I'm going to do, guys, is I'm going to leave these questions here just for a second. If you need to pause the video and if you need to make any corrections to your work, it's really important that you have the right answers going forward. Okay. All right, that is the end of the first lesson on electricity. We have now figured out what charge is. Charge. What is charge? That's a really important takeaway message from today. So try and answer that question. Speak your answer to the screen right now. What is charge, please? So what is charge? Speaking your answer now. Okay, charge is a property, which means a property of a substance is a feature that we can measure or we can see. Charge we can measure. So charge is a property. We can take a material and can measure its charge. So it is a property. That's a really key take home today. What is the charge on the different subatomic particles? You need to know that. That's a take home. So speaking to the screen now, what is the charge of each subatomic particle? 1, 2, 3. Okay, protons are positive or +1. What are the other two? Electrons are -1 or negative, and neutrons are 0 or neutral. Okay, again, if you got that right, brilliant, guys. We're on the right track. What do we have to do to make a circuit? Speak your answer, guys. If you weren't sure what I wanted you to do there, speak your answer. To make a circuit, we need to take a metal wire. Why metal? Because they're conductors. Metals are conductors. And we need to close the loop. So we need to make it a round loop. That's what we need to do to make an electric circuit. What else do we have? Why are metals good conductors? Why do we use metals to make wires from, basically? On 3, 1, 2, 3. Okay, we use metal to make wires because they are conductors, because they have delocalized or free electrons in them. Last bit, guys, what is a coulomb? Okay, a coulomb is a number is equal to 6 quintillion, and it's what we use to count electrons. So we have 6 quintillion electrons in a coulomb. All right, guys, well done. We will see you in the next lesson. I look forward to seeing you guys. If you need, if you just give the video a like, it helps other students outside of my school to find the video, and it might help a few other students. If you could subscribe to the channel as well, guys, it's easier to find it for future lessons. And the last thing, if you need any other help, if you need me to make any videos for revision, it helps me prioritize. If you put a comment in the underneath the video, it will help me know what you guys need the most help with. Okay, I'll see you in the next lesson, guys. Bye bye.